Alright, hey class, I just wanted to do a quick review of a couple of the things that we've been going over and just kind of make sure it's clear in all of your heads. So I want to introduce a new property and then review two of the properties we've already talked about. So we've talked a lot about the commutative property both in addition and in multiplication, and all it says is that if I take two factors and reverse the order in which I see them, I will still get the same product. So 2 times 4 we know is 8, and 4 times 2 is also 8. So just by reversing the order of the factors, I'll get the same product. This is actually the property that tells you that you only have to know 36 of the 72 multiplication facts to know all of them. So really you're learning half because of this property. The other one that's new is the identity, and what it says is that any number times 1 will be itself. Okay, so 5 times 1 is 5. So any number multiplied by 1 will be itself, okay, or the first factor here. The associative is the other one, and what this says is that it doesn't matter the order of the 3 numbers as long as they're the same 3 numbers, as long as I use parentheses. So notice I said 2 times 3 times 5, putting parentheses around these numbers, is the same thing as 3 times 2 times 5, using the parentheses, and here is why. 2 times 3 is 6. Bring down the 5. 6 times 5 is 30. Okay, and if I do this side, I have to do the parentheses first. This is the key. If I do the parentheses first, 2 times 5 is 10. Bring down the 3. 3 times 10 is also 30. So 30 is equal to 30. Okay, so know that the associative property, as long as you use these same 3 numbers, it does not matter the order of them as long as you use parentheses. And when you go to solve this kind of problem, you have to do the parentheses first. Okay? The next thing that's been getting us a little bit is what this equal sign actually means. Okay? From kindergarten until now, we've been so used to seeing this, and we think, okay, well, the answer comes after it, right? Well, not so much anymore. We have to think about it being balanced or having the same value on both sides. So if I look at this balance, kind of like a seesaw, you can think of the balance telling you equal. So both of these sides must equal the same amount, have the same value. So if I have 131 on the left side, I know that this side too has to equal 131. So it's asked me 112 plus some amount must equal 131. Now there are 3 strategies you can use to find this answer. The first is counting on. Now this is a great strategy if these numbers are somewhat close together. If it's a larger amount or there's a lot of space between them, you might run into an error because you're going to be counting on for so long. So you would put 112 in your head and then count up until you get to 131. Now you could count up in your head. It might be better if you tally each time you count, and then that way you'd be less likely to make a mistake. Okay? The other way you could do it is go back to your math mountain. Remember, in our math mountain, the very top is going to be the total. In this case, I want to get to 131. That's what I want this side to equal. I know that one of my add-ins at the bottom is going to be 112, and I'm going to add it to some other add-in to get 131. To do this, remember, you have to subtract. Okay, that's why I put that there. 131 minus this add-in will give me the difference, or this amount. And I did that for you here, and you would get 19. Okay, the last strategy, and this can only work if you have multiple choice, and that would be just to plug in the answers. Plug and chug, as we call it. So you could take 112 and add 22, add 21, add 20, and add 19. Eventually you will get to the answer where it equals 131. Now this strategy will take you longer, but it's a great one to use on a multiple choice test if you're not sure. Just take your answer choices and plug it in to what you're looking for, this question mark, until you get 131, which is what you're looking for. Okay? All right, let's do some practices together. Okay, the first one, 2 times 4 is equal to 3 plus some number. So because I don't know this side, I have to start on this side to find what my total needs to be. So 2 times 4 is 8. So 8 must equal 3 plus some number. Now because these are close together, I can simply count on. I can say 3 in my head, 4, 5, 6, 7, 8. And I counted on and got 5. Now don't stop here. You need to check your work. Okay, so now I'm going to say 3 plus 5 is indeed 8, and 8 equals 8. So I know that 5 is my right answer. Now what if I had accidentally said 3, 4, 5, 6, 7, 8 and gotten an answer of 6? Okay, this happens all the time. Sometimes we forget to put 3 in our head and then count on, and we'll count 3 itself. If I had gotten 6 and just moved on, I would have been wrong. But if I go back and check my work, I would have seen that 6, 7, 8, 9. That 6 and 3 is 9, and this would be incorrect, and I could go back and rework it out. Okay, moving down here, I have 32 plus y equals 24 plus 12. Again, this is the side. I don't really know what this is yet because I don't know what I'm looking for. I have an unknown here, y. So 24 plus 12, I can figure that out. 4 and 2 is 6. 2 and 1 is 3, 36. So I know that 32 plus some number y must equal 36. Okay, I see here that they are close in numbers, so I'm just going to use the counting on. So I'm going to put 32 in my head and count on 33, 34, 35, 36. Okay, and I've counted on 4. So I think that y is 4. Let me check. 32, 33, 34, 35, 36. Yes, I am correct. So the correct answer, y, would equal 4. Moving on over here, I want to use the commutative property to show another way to write 2 times 8 equals 16. Well, I want to stop and think. I'm not even going to look at these answer choices. I want to think about the commutative property and what I remember. And remember that if I take these factors, which are these two numbers, and reverse their order, I'll still have the same product. So I'm going to look for an answer choice that says 8 times 2, which is B. Please know that they will throw in another answer that also equals that product, but these two numbers have nothing to do with these two factors, okay? So you could eliminate that. They're also going to throw in some of the same factors just to trick you, okay? You have to eliminate these two answer choices, though, because the product doesn't even match this product, okay? All right, couple more. Here, I want us to practice the associative property. So I want us to look at each of these equations and check off the ones that are an example of the associative property. Remember what I said. It's 3 numbers, and you can change up the order in which you use them as long as you use parentheses, okay? So here I have 2 plus 3 with parentheses, and then I have 2 plus 3 plus 3. So yes, this would work. I have parentheses, and I have the same 3 numbers, just in different orders. If I checked this, 3 plus 2 is 5, doing parentheses first, plus 3 equals 8. And then 3 plus 3, because it's in parentheses, I have to do it first, is 6, plus 2 equals 8 as well. So there, I checked it. It does work. True. Now I have 1 in parentheses times 2 equals 2 times 1 in parentheses. Okay, I can eliminate this choice for a couple of reasons. 1, I don't have 3 numbers. Okay. 2, these parentheses mean nothing because it's nothing I can do in them. Okay. So the reason we use parentheses is to tell us to do something, but in these parentheses I have 1 number. I can't do anything. So these parentheses really don't matter. This is actually showing more of the commutative property, okay? So no. Here I have 4 times 2 times 1 and 1 times 2 times 4. I do have the same numbers, 3 of them. They're in different orders, and I have used parentheses. So let's check. 2 times 1 is 2. Why did I do that first? It's in parentheses. Now I'm going to multiply it by the 4. 4 times 2 is 8. Over here, again, I have to do parentheses. 2 times 4 is 8 times 1 equals 8. Okay, so they do work. Okay, down here I have 3 times 4 times 2 and 3 times 4 times 4. Now while I have 3 numbers and I am using parentheses, this is not the associative property because notice I have 3, 4, and 2, and then I have 3, 4, and 4. This number would have to be a 2 in order for this to be an example of the associative property. Okay? So no. Alright, here's your homework. 3 times 4 is equal to 15 minus triangle. You need to solve for the triangle. 8 times 1 equals 8 is an example of what property? Just tell me the property name. 145 plus 12 equals 200 minus question mark. You need to solve for the question mark. 6 times 8 equals 8 times 6 is an example of what property? Again, you can just write the name. 18 is balanced by 6 times what number? So solve for that question mark. Now I'd like for you to create your own example of the associative property. Do not use one that we've already done in this video. You need to create your own. Show me that you're understanding what this associative property means and what it is saying. And lastly, 28 minus y equals 12 plus 8. So I need you to solve for y. All right, good luck.